So we are going out of time, so I am starting now. They will come in the meantime. So good morning everyone. I am Gopal Sahoo, scientist B chemist from Central Groundwater Board, Northeastern Region, Guwahati. So today I will discuss on water chemistry and geochemical analysis of the spring water. Till now you have taught much about the quantity of spring. So now we will learn some about quality of the spring water. So before starting I will just say that this presentation mainly consists of how we are collecting our samples, how we are analyzing the sample in our lab, what is the protocol to submit the sample. So what are the protocol, then getting the result, what we will do, how we will analyze the data, everything we are going to discuss. Before starting, I have just one simple question. Can anyone tell how many people of India are dependent on spring? Any rough idea? Exactly, near 200 million. So first one is when we talk about issue, the major one is the quantity issue. So you have taught much about quantity issue because spring are getting seasonal or by drying day by day. So you can see that water stress percentage by 2040, India will be in 40 to 80%. That is highly water stress region. So apart from quantity issue, we have the quality issue. We know water is H2O, but not only H2O, water also contains some minerals. We will say minerals till it is some below limit. So it consists of some trace element like arsenic, manganese, iron, nickel, cobalt, all the heavy metals are in trace element. Then some inorganic constituents like chloride, nitrate, sulfate, organic contaminants like pesticide residues, pharmaceutical residues, microplastic, nanoplastic. Some radioactive atom are also found currently in water like uranium and radon. So all are the major concern for quality issue. So contents of this presentation is like water chemistry, then geochemical analysis of spring water, assessment of spring water quality, demonstration for graphical chemical data interpretation. So water consists of two hydrogen and one oxygen atom. Hydrogen is partially positively charged and oxygen is partially negatively charged. So this charge differentiate makes two hydrogen atom attract to each other and makes hydrogen bond. And for this we get three type of state of water: solid, liquid and gas, depending on the temperature. So next topic is the isotope. Isotope study of mainly spring water is very much essential, because by studying isotope study you can get the idea where is the recharge area, how much it will how long it will give the water. So everything we can get by isotope study, but it is a long study. So isotope are the atoms with the same proton number but different neutron number. So hydrogen has three types of isotope: protium, deuterium and tritium. Among them tritium is radioactive and remaining are stable, and oxygen has 16, 17, 18 isotope. So when these two type of isotope combines, we can see that the top figure, out of almost 3000 molecule, water molecule, one molecule has the chance that it will have one deuterated hydrogen atom. And this is the equation by which we get the isotopic composition, where R sample gives the isotopic ratio of your sample and R Vosmo is the isotopic ratio of the standard solution, and it is expressed in 1000 parts per thousand. So this is the global meteoritic water line, where the station from this right side map, you can see that from that station precipitated sample was collected, and during winter and summer precipitation this give a general straight line. But when lake sample was plotted here, generally there is evaporation in the lake sample, so we can see that there is some deviation from the straight line. So from this we can conclude that if there is some rock water interaction, we will get the line along the x axis, and when there is deuterium exchange, that is H2S exchange, we will get along the y axis, and evaporation will give in between these two axes. So this is a special case study of bark taking 28 spring of Uttarakhand and 18 spring of Himachal Pradesh. It was found that there is some altitude effect as we go above the hill. So after each successive rain, what will happen? After first rain, heavier isotope will come first, and then when we go above the each successive rain will become with a lighter isotope rich. So you can see that the del 18O dash amount is decreasing, that is minus value is increasing, means higher isotope value is decreasing. So from here we also can determine the resident time of the spring also. Most of the spring in these studies was covered, was found that it has a tritium unit of 6 to 8 tritium unit, and rainwater has a 8 tritium unit. So we can say that most of the spring was freshly recharged. Now come to the water characteristic. So water has three type of characteristic: physical characteristic, chemical and biological. Under physical characteristic we generally found is color, turbidity, odor, taste, pH, EC, and in chemical we generally found the major cation anions present, metals, radioactive elements and isotope. And biological study we get the dissolved gases, microorganism, pesticide, microplastic, BOD, COD. This is just a idea of TOC. TOC is a total organic carbon, that is the decaying vegetation and bacterial growth. And dissolved organic carbon, this is the remaining sample after filtering the sample with 0.45 micrometer filter. So DOC combining with organic particle will give the TOC. So as I told that the element which is present in water we will call it nutrients, minerals, till this is some below some limit. So these are the minerals, major minerals which is present in water, and their biological function in our body. And this is the micronutrients which are present in water and helps in our body. But when these cross the certain limit, that is permissible limit given by BIS or WHO, then we will call it as a pollutant. And it has some sources from which these pollutants are coming, and what are the negative effect on the human health has been given here. You can go through it. And these are the some treatment process. If there are the pollutants in the water, how you can remove that from the water system. So the most major concern is the arsenic in water. So in some of the northeastern region we have found arsenic in groundwater. So arsenic have two state, arsenic 5 and arsenic 3. So this 5 is called arsenate and 3 is called arsenite. So among them arsenic 3 plus, this is the most toxic. So if it is present, it will be harmful to our body. So arsenic has some geogenic, anthropogenic and biogenic sources. This is the reaction mechanism by which arsenic is coming in the water. First step, you can see that some arsenic rich pyrite like AsFeS, when it gets in water, it will make arsenate H3ASO4, and it gets absorbed on oxyhydroxide, that is FeOOH. When this come with mild acidic condition, it will be dissolved. AHD means it will be dissolved in water. Then arsenic is released in water. So these are the some geogenic and anthropogenic sources of arsenic. The minerals are mainly realgar, arsenopyrite, orpiment, and anthropogenic sources are use of phosphate fertilizer and pesticides. Overexploitation sometimes gives lowering the groundwater table, then concentration of arsenic increases. And as the arsenic contamination occurs, we can see that there is some arsenoconosis disease, that is lung cancer, skin cancer. So arsenic is actually called the poison, king of poison. This is the highest level of contamination. This is the instrument in our lab by which we are determining arsenic. First one is AAS, then by ion chromatograph we can also determine arsenic, and the latest instrument is the ICP-MS, by which we can more accurately determine arsenic. D and E are for field purpose. We will have some strip by detecting the color by giving it into the sample and taking its color matching with some reference, we will get the idea how much is arsenic is there. Next important parameter is the fluoride. Fluoride also have some geogenic and anthropogenic sources. Mainly geogenic sources are fluoride, fluoroapatite, cryolite, topaz, and anthropogenic sources are the synthetic agrochemical used in tea garden, etc. So when there is fluoride above some limit, that is the limit of fluoride is 1.5 milligram per liter. Mainly dental fluorosis and skeletal fluorosis occurs. You can see this type of picture. So mainly we can determine fluoride in our lab by ionometer and UV visible spectrometer, but this ion chromatograph is the most advanced instrument for analyzing fluoride. Now geochemical analysis of spring water. This is some general procedure by which we are collecting the sample. We have some policy making and management plan. We first collect the sample and then preserve the sample with some acidic some acid, and then we analyze the sample in the lab. Then we follow some procedure. These are the some procedure in our lab. So these are the procedure by which we are collecting the sample. First is the analyze the sample parameter like pH, EC, temperature, etc. immediately in the field. Tomorrow we have the field visit. We will show you how to determine pH, EC, temperature immediately at the field. Then for basic parameter we collect sample in polyethylene bottle in 1000 ml bottle. But now if we go for analyzing in IC, we can lower this volume to 500 ml. And for heavy metal analysis we add some acid. Mainly nitric acid, sometime HCl also, to lower the pH below 2. And for determining the heavy metal in AAS, we have to collect the sample in 500 ml, but for ICP-MS 60 ml is sufficient for heavy metal analysis. So this is the sample collection and sample submission format by which if anyone want to submit the sample to our department, they have to give this type of Excel prior permission of the regional director. So these are the some how we are monitoring our sample location. So we are going to do the background monitoring in every 5 years, and then taking the location where there are some contamination, we are monitoring that location called trend monitoring. That is every year taking pre and post monsoon sample. And for special purpose monitoring, we select some selected area where contamination is high level. I will show in the next graph. Taking this is called hotspot area, and taking 5 square kilometer radius, and each grid of 2 by 2. Then collect sample from each grid. For special purpose monitoring, the sampling location can be anything from agriculture or urban cluster, industrial cluster, or some our NACIM studies or NHA studies, and generally iron, arsenic, uranium, or including another 2 heavy metal, which is the location demanded. This major parameter along with EC, fluoride and nitrate, these are the major parameters which we determine in special purpose monitoring. So these are the major instrument by which we are analyzing these parameter in our lab. pH by pH meter, EC by EC meter. Though pH, EC are determined in the field only, but we also determine in the lab condition also. Then we have some trimetric method also, and some advanced ion chromatographic method also. So this I have already told. These are the some checklist during field visit, and these are the sampling procedure. So after submission of sample and analyzing the sample, we are going to check whether our data is correct or not. For that we have to check percentage of balance error. So we convert all our cations data into millimole and anions data also in millimole, then summation of that cation and summation of anion, then from this equation we get the charge balance. If that percentage of error is in between plus minus 10%, then we can tell that our analysis is okay. But for very dilute solution, slight difference will give high fluctuation, and for some saline water like TDS above 10,000, then we also get the high error. So in these two cases, that plus minus 5 or plus minus 10 is not accurate. And from TDS, we also calculate TDS from EC by multiplying EC with 0.55 to 0.95. So these are the format for water quality data sharing. Now assessment of the groundwater quality for drinking, irrigation and pollution index. These are the limit for beach drinking water. So every parameter has some certain limit. If the water quality parameter is within this limit, we can say that okay, this water is good for drinking. So like pH has the limit 6.5 to 8.5, TDS have 500. So beyond that we must think how we can bring that water in this permissible limit. So here all the parameter have some permissible and acceptable limit. So these are the some data presentation type for post monsoon and pre monsoon sample. In the right side we have the BIS and WHO limit, and the left side we have the check pH value with minimum, maximum, their mean value, standard deviation value, and how these are varying with season. We can check by tabulating this type of. Then the important parameter is the irrigation feasibility. So for irrigation parameter, we generally determine this sodium absorption ratio, magnesium hazard, RSC, PI, percentage sodium. For that we have to convert our data, like sodium we get some value in milligram per liter, we have to divide it with its equivalent weight, then we will get some millimole data, then we have to plot that millimole data in this equation. For SAR it has separate equation, MH, that is magnesium hazard, it has a separate equation. By plotting here we will get all this irrigation parameter. Another one is the Piper diagram and USSL salinity diagram. If we plot the data here, we can easily identify whether the water is freshly recharged or whether it has some seawater intrusion or mixed type of exchange. We can see all of these can be seen from the Piper diagram. And from USSL salinity diagram, if we plot the data here, we can check the how much it has alkalinity hazard, how much it has salinity hazard, and whether it will be suitable for irrigation or not. So here you can see clearly that C1 is the below axis, that is C1, C2, C3, C4, and that is the horizontal axis S1, S2, S3, S4. C1 has the lowest salinity and S1 is the lowest sodium hazard. So any data falling in C1, S1 is good for irrigation. As we move from left to right or below to above, the quality for that water for irrigation purpose degrades. So this is some comparison. We can see that from the same location data was collected, and in 1992 to 1996 it was in good to permissible limit, but in 2000 to 2004 the same well show some doubtful to unsuitable region, and in 2005-06 it was in unsuitable region for irrigation of the same location, that is the water quality of that location was degrading day by day. This is another some Collins bar diagram. From here anyone can tell which one has some seawater type intrusion in which aquifer without reading below things. I am telling that just look this one. So this one is sodium plus potassium. So here it is sodium plus potassium, and this is chloride. So left side you can see that sodium and chloride was lesser, that is in shallow aquifer, but in deeper aquifer we found that sodium and chloride is high. Sodium and chloride means some seawater intrusion occurs there in the deeper aquifer. So shallow aquifer was suitable, but deeper aquifer was not so much suitable, both for irrigation and drinking purpose. Another one is that in 1977 the same well, in 2008 we found there is some anthropogenic activity, the red bar, which shows some nitrate concentration. So nitrate generally come for some anthropogenic activity. So the nitrate is also very much dangerous for our health. So there is anthropogenic activity, and suitability of this water goes down. This is Kohler diagram. Again here we can see that in shallow aquifer the nitrate concentration have some varying concentration separate. So we can told that here some anthropogenic activity has occurred, different concentration of nitrate has spread throughout the location, but in the deeper aquifer we can say that most of the sample have same nitrate value, that means the nitrate is not spread out, that is not affected by anthropogenic activity. So this is the pipette diagram. Again here typically we have shown which if the sample fall in any box, which type of water it will be. Then this is the some trend location in chloride of the same location. You can see that as the times goes there is some seawater intrusion, and that is chloride ratio is increasing day by day. As the chloride value increases, electrical conductivity value is also increased. So this is some comparison for your understanding. If you plot chloride by sum of the anion and the value if you found greater than 0.8 and TDS is greater than 500, you can say that there is some seawater intrusion. Like this I have tabulated all the things here. By calculating this type of ratio you can conclude whether there is phase recharge, whether rainwater or some seawater intrusion, ion exchange process or reverse ion exchange process, you can conclude from this table. This is a chart dash plot. This is the modified version of pipette diagram. From here also you can get the idea whether this is recharge, phase recharge or seawater intrusion or mixed type of cation anion is there. Everything you can calculate it, and this is very much simple process than pipette plot. This is another one that if you plot chloride versus sodium, you can get some idea whether there is halide dissolution or ion exchange mechanism, and this type of bivariant you can go through. Another one is calcium magnesium versus sodium. So if sodium concentration is high, that is clay particle generally contain sodium. So when fresh water is coming, it will exchange calcium magnesium with sodium. Sodium will come in water and calcium will go to clay. This is called ion exchange mechanism, and the reverse process is called reverse ion exchange. So in ion exchange there will be sodium in excess. So you can see that ion exchange process, that one, everything is in ion exchange, and where calcium magnesium is high, that is reverse ion exchange mechanism is there. And if you plot calcium and sulphate, gypsum has the that is CaSO4. So if that falls under that line, we can say that gypsum dissolution, and above below that is indicating. So this is some comparison in 2017 to 2021. For that left side, you can see the trend of EC was like that, but in 2022 there is some increasing trend in EC. You can see that some area has got much red area, and some bluish region got green area. That type of change has occurred there. And then this is one decreasing trend in EC, and increasing trend in EC is also observed in location to location. This is the average nitrate distribution. Again we found that in 2022 many modes location was found to be contaminant by nitrate. So this is the nitrate trend, how much location was below 45 and above 45 from the region 2017 to 21 and in 2022. Similar trend analysis with fluoride, just same thing. So this is the summarized. If the EC value is less than 75, we can say that this is fresh water, and if it is nearly 750 to 2250, we can say that moderate. Above 3000, highly mineralized. These are the range, and these are the 15,507 is our number of sample, and these are the percentage of the sample which falls in this category according to 2022. So these are the same type of things. This is for EC value, how many samples are above 3000 and percentage of the sample, and this is for the chloride distribution having greater than 1000 milligram per value liter. This is for fluoride. And this is again some comparison for state wise. Fluoride value greater than 1.5 in 2015 and 2022. In most of the cases we see that value has been increased, though there is some decrease in some state, but most of the cases location affected with fluoride has increased. So these are some trend in fluoride. This is the nitrate distribution in India. This is iron contribution. You can see in all the cases northeastern region is free from the type of contamination. Nitrate is not there. Again fluoride is in some location, mostly fluoride is here in northeastern region, major contaminant, but that is also located in only some location only. This is a comparison in iron in 2015 and 2019. You can see that there is some high increase in 2019. So this is the arsenic distribution, where arsenic have 10 ppb, that is 10 microgram per liter, mainly along the Ganga river basin arsenic is located. And then uranium, northeastern region we don't have any uranium contaminated location till now. This is mostly found that western part. So this is the number of district affected by uranium. So this is the paper which I was showing how you can draw. For this you must have this type of Excel, then paper diagram. This is an YouTube video, you can go there and you can check how you can draw this parameter. So that's it. It's our lab in the near Guwahati. These are some clippings from our lab during analysis. This is our NABL lab, some NABL audit long back ago. So these are some analysis. These are the field kit. Below one is the field kit, we will show you tomorrow. These are some clippings. Training students come in our office, we give them some certificate also. So all about my presentation. Thank you. So if you have any question you can ask. Okay, then I finish. सर बुलाना पड़ेगा क्या है क्या सर
Thank you.